Morning. Seems like the speaker in here is not working.
Oh, you cannot hear me?
Yes, I can hear you.
Oh, okay.
But the speaker in this room is not working. I don't know why.
Oh, the big speakers, right? Okay. Is anybody in the classroom? We cannot see.
Okay.
Is anybody in the classroom? We can't see from here.
No one.
No, just you. Okay.
So okay. Seems like the internet network in this room is not working again.
Uh-oh.
Okay, for today is a Gaussian mixture model GMM. That is the one of the unsupervised learning. That is, we will have the data set of X from X1 to Xn. So for each sample has a Xi, and it start from the generated model by sampling C from multinomial distribution over cluster 1 to K with the probability zeta 1 to zeta K, and sample X from the normal distribution from with mu C and sigma C. So from the EM algorithm, we begin to guess parameter zeta 1 to zeta K, mu 1 to mu K, sigma 1 to sigma K, and try to optimize this parameter go to the steady state. So first of all, we build the GMM model for dataset. So from here inside has with the mean parameter 110, 10, 1, and 10, 10 with the SD 1001, 4001, and 1004. And then we try to have the ground truth higher probability for each cluster and create data set. Then after create a data set, we try to visualize them. And run the EM algorithm. So in the EM algorithm, here, this is initialize. From the initialize, so we try to random some data at first, but now is for the order. This is a random. Auto thing just set up the parameter from the 0 and change phi to be 1 divided by K. And sigma is just a identity matrix. Then when we have the iteration of the GNN, we try to start from create the Gaussian of a pj for each x parameter and the average and sigma. And then try to find the which one is the relative weight for each cluster. Then adjust mean and sigma again. Then done. Okay. Then try to run the model. After we try to run the model, the output get like this. This for the parameter inside here, that's not the same as everyone because we have random in different state. And here is a average and sigma like this. So if we can remember that the parameter that we have been random at first for the sigma is a 4 allow for 0 1 0 1. So it look alike, same. It's for the in-class exercise, we try to determine how close the estimate parameter phi, mu, and sigma are very close to the Gauss value at the beginning of the experiment or not. Then next, try to find the outlier. That the outlier is the some points that it should not be calculated because it is over from the normal parameter too much. So we remove that. Then in the outlier probability is 1%. Then after try to adding the outlier, we can check the inlier and outlier from the GFM model. Okay, so from the outlier that you can see in the red circle, that it should not be calculated. So for in the class exercise, understand why and explain about the outlier class for each cluster. More give us more outlier for the broad cluster than tight cluster. Then read about Malahanovic distance of the point to mean. So distance. Malahanovic distance. What's the math? What is it? Seems like
it's just a distance measure that takes into the account the non-spherical is this Mahalanobis? Yeah, the non-spherical nature of a covariance matrix. Yeah, so like you see in this diagram, the distance to the mean is measured according to these isocontours, kind of like how many how many isocontours do you have to climb up to get from wherever you are to the top of the mountain, rather than just the Euclidean distance, right? So the distance is related to how far you have to go up the mountain, right? Rather than the distance in the plane. That make sense? In a one-dimensional, if you have a one-dimensional Gaussian, the Mahalanobis distance of a point to the mean is just the number of standard deviations from the mean that we're at. But in a two-dimensional situation, then we have a elliptical covariance, and so we're counting the number of standard deviations in this elliptical sense.
Okay. Okay, first notice about the heart threshold for each cluster and read about the Mahalanobis distance of the point and explain what is Mahalanobis and why code the Mahalanobis. Okay, for the code in the Mahalanobis is we have give you some step of the calculation inside here, but you need to rewrite it yourself. Okay, then next is we have the tactile customer segmentation from the last week data set. Not last week, is last 3 weeks ago. More customer, the CSV that has been inside in here. So check the more customer. And try to use the initialize GMM. Internet in this room is broken. Please wait a moment. Internet in this room is gone. Now internet is die. And I use my own internet. That's why I can connect. First row represent annual income and second row represent the spending score. This value change in every iteration. So its data is has a 3 categorized right here. Then try to visualization the parameters inside. Okay. After we try to make the GMM, you can see the data output of the GMM is like has a 3 parameters in here. And this is the group of the some small bad value. And the outlier has a lot outside here. Then for in-class exercise, exam the cluster center and determine whether can find reasonable interpretation of them. Try to do k-mean and compare the result. Then try to use Mahalanobis distance in the for the first example. For the third example is the Nguyen Han tutorial on Medium that use data set online retail from Kaggle. So we are using everything same. But data set has a lot size. And we try to reduce some parameters. Has a missing check the missing percentage first. Then total sum has something missing. Country author thing not have the problem. So we try to change NaN to be 0. So after that, we have the categorize to numeric. Change the country name to be number. Change author thing to be the text string to be value. Then check the mu and sigma. Find outlier. Then we try in the exercise in the third example, we try to make the GMM code in the dataset on the third example. Try to interpret the result, plot inlier or outliner too, and in Mahalanobis distance threshold, plot likelihood function of K. Determine whether there is an elbow in the plot. So check how many cluster you should use. So you should try to find the cluster group such as k equal to 2, k equal to 3, k equal to 4, and find the elbow of the separation. Which one is the best elbow? Okay, so today is done. Anything else or additional in the GMM today, Dr. Matt?
No, that's good. We can follow that. Maybe start working on it, and then if there's any questions, go ahead and ask.
Seems like no one. So should we start on the discussion or let them?
I think we should give some time for the lab part first, right? Maybe until 9. What do you think?
Yeah, depend on you. Okay. 9 we will start the project discussion. So should we have some totally random or not?
You mean for who goes first?
Yes.
Okay, yeah, I'll randomize them. Wow. Where did you get these projects? Okay.
แล้วเราธนุษยากอบการ
Yes, Professor.
Okay.
Okay, I will share the screen. Can you see my screen now?
Yep.
Okay. So our topic is insurance distribution prediction by Bank of Portugal. Member is me, Panancia, Paramik, and Gopgan. And for the domain, our client is a multinational Portuguese bank, and they want to predict whether the policyholders from the past would like to avail of more type of insurance specified to home and car insurance. And insurance is a policy that a company or bank undertakes to provide a guarantee of compensation for specified loss, damage, or death in return for the payment of a specified premium. So our group objective is to build a model to predict whether a customer interest in vehicle insurance or home insurance or not. And the bank can plan to communicate strategy to reach out for those customers and optimize their business model and revenue. So this is the data set. Our primary data set is bank data set. We have variable age, job, marital, education, default, housing, and so on. And we discuss to merge data set with another data set. The second data set is home insurance, but we select only some variable such as quote date, cover start, and building and year built, as you can see here. And the third data set that we select to maybe merge with is the car insurance. And some variables are ID, gender, region code, vehicle age, and vehicle damage. So our target variable is, as you can see, 0 is customer only interest in home, 1 for car, and 2 for both, and 3 for not all. Yep. And the algorithm that we will do is logistic regression and decision tree or random forest. Yeah. Thank you. Any question for our group?
Maybe could you say more about how you want to merge these data sets? How can you put them together?
Paramik, could you help?
Yeah, so Professor, what we are thinking, like, we will carefully analyze the 3 data sets, and we will kind of make a synthetic data set based on, like suppose a customer who has previous car loans, or a customer who has previous housing loans. So we will kind of merge those data and kind of create a synthetic data set, after which we will implement the algorithms.
Okay, but it's a bit confusing because I mean these data sets don't cover the same individual people, right? So then
Yeah.
So Yeah, okay. I think you need to be more specific about how you're going to do that. Yeah.
Yeah, so like both the data sets have different sets of people. So we were thinking like maybe kind of get a subset of people from both the data set, and one of the data sets should have maybe the housing, and another one has the car. So maybe we can assign, like if one data set has only person who has only home insurance, maybe we can assign them car insurance also. Basically, generate a new type of data set out of these three data set.
Okay, but then finally, then you have to come back to data set 1 and then predict these 4 classes, right? More accurately. Is that right?
Yes. So maybe we can reduce into 3 classes, like a person having only the bank data set. I mean, predicting whether the person should be given a a housing loan or a car loan or both. So these are the 3 Y classification scenarios that we are thinking of.
Okay, but there are some that do not buy any, are not willing to take up any insurance, right? So then,
Yes, I maybe we should not include the number 3, not at all. Maybe we should only focus on 0, 1, and 2.
well, okay, so anyway, so let's, I mean, it sounds interesting, but let's be more clear precisely how we're going to link these data sets together, right? And or the synthetic data, how you're going to generate it, and then how will it be used to build your model, right? Yeah. Okay.
Yes. Instead of random the value in each variable, we just select from another data set like that, instead of just make the data. But-
Okay, yeah, that's fine. But then finally, how you have to be clear how that's going to help you, right? How is it going to help you solve the original problem, right? So, so I'm imagining that you're going to somehow use the information or statistics from the housing insurance data set and the car insurance data set to provide some information about the likelihood of a person in the first data set to take up the home or car insurance, right? So get some something about the distributions or something like that, right? So anyway, let's clarify. Maybe you can write down an algorithm, right, as to how you're going to use these data sets together, right? And we can talk about it some more. Okay. Thank
Yes.
you. Okay, good.
Thank you. Thank you, Professor.
Yeah, next. Everybody, please turn your cameras on. Just make your friends feel at home, comfortable, friendly.
Santos, Sakan, Ayush.
I thought it was a caption bot.
Hello.
Yeah, okay.
Am I audible? So can you please share the screen?
Oh, God, don't crash.
Can you see my screen?
Yeah.
We can.
Good morning, everyone. I'm Santosh Sungana, and I'll be presenting on behalf of my teammates. We're planning to actually implement the statistical downscaling of global circulation model using the machine learning algorithm. Let me quickly walk you through the presentation. Yeah. We might have heard of the climate change, and it's posing a severe threat to on the humanity, and it's projected to, or it's likely to exacerbate in the near future as well. So the effects of the climate change are rising temperatures, rising sea levels, unpredictable weathers, loss of wildlife, biodiversity, and all. So it is of utmost important that we project the future climate as of now, and then implement the or formulate the appropriate mitigation measures to combat the climate change issues. So in order to do that, several agencies across the globe have come up with the global circulation model that simulates the Earth's atmosphere and project in the future how the climate is likely to be based on the several scenarios or the increase in the carbon dioxide concentration in the atmosphere. But the problem with the direct use of these the data set from the global circulation model, whatever we obtain the precipitation and the temperature, is that the global circulation model is of very coarse resolution, more than a grid cell. Grid size would be of more than 100 kilometers. But at the local scale, what we call watershed, at the watershed scale, the direct output may not yield or has biases, so we can't directly use those outputs in the application at the local scale. So in that respect, downscaling is required of this data set. So there are two types of downscaling. The one is the dynamic downscaling. The other one would be the statistical downscaling. The dynamic downscaling is similar to running the global circulation model, but at a finer resolution and at a regional scale with the boundary condition from the GCM. But this requires very high computational power, as well as it's not what we call it doesn't yield the output in a timely manner. It may take years to get those outputs. So the statistical downscaling approach is mushrooming these days. So and lately the use of machine learning algorithm in the statistical downscaling has been adopted. So yeah, this is the cause. I mean, the problem with coarse GCM resolution, more than 100 kilometer, but we need the data at least 25 kilometer or 0.25 degree for climate change impact analysis on the water resources, or to assess the climate change impact on the hydrology of a basin or a watershed. It is also noteworthy to mention that as GCM do not consider the local topographic variation or the topographic effect in order to address the orographic effect of rainfall and rainfall. So we are planning to include the digital elevation model into or the topography into the downscaling, so that it could arrest the topographic variation. And we are planning to use multiple CNN architectures and see how they would perform to our model. Yeah, this is just a general example. We'll have a grid-based data which acts similar to the image, and we'll try to implement the convolutional neural networks, apply different filters, and come up with the coarse resolution image would to a fine resolution output or image.
Santosh,
Yeah, Professor.
So it looks like you're taking reference from some paper or what? I mean, you're using, these are not your diagrams, right?
No. This is just a reference. I mean, just to show how it looks, Professor. It would be for the Southeast Asia for our domain.
No, that's fine. But I mean, when you use a resource from another work, you need to cite it.
Cite.
Right?
Yeah.
Right.
Okay. Yeah, Professor. We'll keep that in mind, Professor. We'll definitely put references. Yeah, and this is the expected outcome. We'll have a downscale climatic variable precipitation and temperature for the Southeast Asia. Yeah. So is there any question?
Okay, yeah. So is this you're gonna follow an existing method but apply it to a new region? Is that the idea?
Yeah, Professor. Maybe we could sort of follow the existing method, but the architecture might be different, Professor.
Okay, so you may experiment, like you said, you would
Yeah.
experiment with different CNN models, right?
Yeah.
But then this study has not already been done for Southeast Asia, right?
No.
Okay, yeah, so that's interesting. Yeah, so anyway, so just please cite your references, and you know, if you use an algorithm that's published or something, be sure to tell us what that is and how you adapted it to the Southeast Asia data. And yeah, I think it'll be
Yeah.
super interesting. Yeah.
Yeah. Thank you, Professor.
Okay, any other questions, anyone? It's an interesting topic. So we're gonna know what's gonna happen in Thailand or at AIT as climate changes, right? You'll include AIT in the study area, right?
But AID would be very small for this one.
Oh, but I mean, you're downscaling, right? From like
Yeah.
what 1 degree down to what
To
scale?
0.25, Professor, 0.25, 25 square kilometer, because mostly our hydrological application would be at watershed scale, and AIT would be very small area up to that.
Okay. Well, anyway, the I guess AIT will be in one of your tiles, right?
Yeah, well, it would be
Okay.
one of the tiles. Thank you.
Are we gonna have another spin, Alisa?
Oh, no question.วันชนกตรงกราฟสับหน้า
Hello. Can you see the screen? Can you hear me?
Yes, we can.
Oh, okay. So our project is about classical music recommendation based on facial expression recognition. So what we do is to objective what we do using using CNN model as a base model to detect the facial the face from the database, and then we classify it by like sad, anger, happy, and then we find a suitable music from the music database. We find a suitable song to recommend on each facial expression. And then this is the overall of the project. And so we have a capture image of the facial expression, and then using CNN to detect the CNN model to detect the facial to like extract the feature of the face, and then we classify music classifier, and then we select the song and play the song. So the model we were using.
Wait. Can you go back? Sorry. Thank you. Okay. So this looks very interesting, but also a bit strange and confusing, right? So, so I mean, the first half is pretty self-explanatory, right? You're going to detect or classify emotions in people's faces. But then how does that go to the music classifier? I don't understand that yet.
Music. So basically, we have a like a happy song, a sad song, and then we play each song on based on the emotion that we got.
So the idea is I go to my computer and I'm feeling sad, so I make a sad face at the computer, and then it will start playing some sad song for me.
Yeah, that
Is that
sound
right?
like a bit irony, but I just thinking about like when we posting on Instagram, right? And then we say a sad face, and then we play a sad song, something like that. It's not like you're sad, and then we play a sad song too, like that.
Okay.
So I'm thinking about like playing song on facial expression is like suitable for like maybe a short video, not for a long one.
Okay, so you're gonna basically help someone who wants to make a short video to
Yep.
come up with a song quickly by just showing their face, their facial
Yep.
expression, something like
Something
that.
like that. Yes.
Okay. Anybody have questions? Saki, what do you think? I'll pick you randomly.
That looks super cool.
Okay. Yeah, okay, anyway, yeah, sounds interesting. So let's be clear, let's try to be more clear about the use case and the scope, I mean, you know, the actual flow or something, right? So how is it going to work? But anyway, okay, please continue, go ahead. I think you have another slide or two, right?
Yeah, I'm sorry, I did expand with more on the song as well.
Yep.
And the model, I think we will like follow on data analysis part. So we have a image capture image, and we do ETL, EDA, and train and speed, and then we create a model as CNN as a base model, and we use PyTorch library to do the classifier. That's what I hope to do. And the dataset is we using FER 2013 for facial recognition, and I think we will use classical music for song database, or maybe like some popular song on song database. We haven't decided on the song database yet.
FER, this is facial expression
Yeah, it's
recognition,
the
right?
image facial expression.
Okay.
Yep.
Happy, sad, afraid, angry, surprised, disgusted.
Yeah, this is the specified dataset. It's in a Kaggle.
Okay.
And it's done. Do you guys have any question about the project? Maybe any recommendation on the model?
Who's excited to use this once it's done? And maybe you could give some feedback.
Okay.
I have a question. Are you guys using only happy and sad emotions? Because usually in emotion classifier, there are like around 7 emotions.
Yes, so basically we will try to using CNN to get the best accuracy. Like we separate in, I think maybe in the folder, if we can. Yes.
Just 2 emotions.
Yep. Thank you for the question.
So hello. So how long to switching the emotion? When example, when I feel good in 3 seconds and another 2 seconds I feel sad.
It's not on like we will have a capture image. So we will using CNN to extract that image, right? And then we will try to detect it's happy or sad or in 7 emotion. It's not like live video we're using.
Not real time.
Not real time, yes.
Okay.
Real time, I think is I'm not sure like how to process that as well. Like maybe you have suggestion?
Yeah,
I have to
how to get there like
yeah. If you have a GPU on the machine that's going to do the processing, then then it's quite possible to do it in real time. You need a real-time face detector, like there are a couple of famous ones that are based on deep learning, right, to detect the face, and then you can pass that face to your classifier, and they can run pretty fast. So that part's possible.
But I think you need like a powerful GPU, right, to do that.
Just a normal GPU, I think.
Normal GPU. Oh, okay.
3070 can, Professor?
Definitely.
I think we are done, right? Thank you.
Thank you. So this will be the highly anticipated demo on demo day.
I hope I can do it.
Super Mario
Okay.
ทศวรรษ and ต้นสน
Okay, let me share the screen. Hello, can you see my screen?
Yes, we can.
Oh, okay, okay. So actually our group project is very simple. Me and Toswa decided to train the how do I say? Using reinforcement learning to play Mario. So our objective is very simple. We want to study the reinforcement learnings by using a deep Q network or maybe double deep Q network. And I don't know if there is enough time, maybe just the vanilla Q learnings. Okay, so our goal is we want Mario to at least clear one stage. And if it's possible, we want Mario to clear the stage without stop moving. You get what I mean, right? I will run to the right. Because we think that if we can make Mario moving non-stop, then maybe he can clear the stage in the shorter time. That's what, please.
So why we use a Q learning, right? I think tomorrow maybe Matthew gonna teach about the reinforcement, right? In the reinforcement, yeah, they're gonna be about the state and action that they provide in each state. The action from the maybe the Mario they gotta do something, but when we using a Q learning, right, they're gonna find the best action that they can use the each state currents. So it's gonna be the how to say in each state, right, and each action maybe they can got some like a reward. But if we use a Q learning, maybe they is gonna got the best reward that they can give it. Yeah, and next one, this is a scope that ต้นสน said earlier. We're gonna test only one one state because from we found, right, if we test off the all the game is gonna take around 80 hours something. Yeah, next slide. This is the reference that we has found. Yeah, that's it.
Okay, good. Thanks. Yeah, I think you're going to run into some computational difficulties, right? But yeah, anyway, it'll be fun to see what we can do.
Yes, from what we researched, I think it's let's say it's manageable with one GPU. That's one decent GPU.
Yeah, but it may take a long time. I guess it'll be interesting to
Yeah,
see. Also, I see online there are lots of existing tutorials like on double DQN and so on. So maybe you should try a model that's not already, not already in these tutorials, right? So for example, a policy gradient method might be interesting. Okay. Okay, cool. Any other questions for the Super Mario team?
No.
What simulator? Where's the simulator? Who makes the simulator for this one?
You mean the emulator for the game?
Yeah.
Actually, there is a library for that in Python.
Okay, so it's not part of GIM, the OpenAI GIM. It's another a different emulator, right?
Yeah, we have GYM as well.
Oh, it's part of it's in GIM.
Yeah.
Is
Okay.
in currently in the gym has a Super Mario emulator.
Yeah. Yes.
Yeah, but I don't know much about how much of the stage, how many stage that they contain.
It's much more complicated than Space Invaders or one of those type games. Anyway, okay, cool. So yeah, good luck. Any other questions?
Okay. Nothing. Thank you.
Okay, thanks.
Turn on white.
Hello, sir. Wait, let me see. As I'm now doing waste classification for formulation of the knowledge. And in AIT and most of the places, we are using manual segregation. Manual waste segregation that is not good. If we through in the same in all because of other reason, if the waste are mixed, that is not good for the environment. It can create diseases. We need to pick the garbage in the time because some waste cannot stay in the bin for a long time. There is a trash waste that can handle the environment. So we need to know that recycling really is very important. That's why classification of recycling awareness and waste is very good. That's why. And I'm also doing smart waste. Waste is kind for my research. That's why I want to do. That's why I want to do this title. I want to classify the waste and category. Let's talk about people. That's why. This evening, for the CNN, I'm not sure yet. And I will get the database from career to train the data and to test. I will take photos of VSP. Actually, I want to do real-time classification. Yeah. And I will get the data from high camera or something. Yeah. That's all. I want to do this. Yeah.
Okay, it sounds very interesting. I notice whenever I at AIT and I take my trash out to the garbage cans, it's hard to figure out which place is supposed to go, right? And then I look inside the trash cans. It doesn't look like anybody knows which ones go where, right? Because it's all the same. It's all mixed up everywhere, right? So
if we can classify the garbage, we can do automated, waste garbage bin, and we just need to do all the tests and it will classify and there will be segregated parts in the garbage bin, It was automatically true based on the work week.
Okay, but yeah, I'm not sure about the feasibility of, covering every trash can inside an institute, right? It sounds difficult. Not to mention the weatherproofing and all that, but anyway, okay, so sounds interesting. So I see there's lots, there's this waste classification data set on Kaggle, right? I guess you're going to use that one. And there are lots of tutorials on using CNNs for those data, right? So I would just like to see that you're not just implementing one of these tutorials, right? That you're going to try different models perhaps, and then of course use your own data as well. Probably you want to train on the Kaggle data set and then try to fine tune your model on the AIT data, for example, or the local data, right? Okay. Could you hear me? Tune on my. Oh, we can't hear you now.
AIT,
We cannot quite hear you.
Hello, can you hear me?
Yeah, now we can.
Real-time classification.
Okay, you're going to make an application. Is that right? Okay. So anyway, let's see what you come up with, and yeah, good luck. Anyone else have questions? Yeah. So anyway, yeah, try the different categories of the trash at AIT, right? There's, what is it? Biodegradable and different kinds, right? So anyway, let's see. Okay, very good. Yeah. Next. Okay.
Congratulations for the lab.
Hi, can you hear me?
Yep.
Let me share my screen. Good morning all. So the project that I'm eyeing it to do at this semester is image augmentation based on GAN. Is my screen visible?
Yep.
So the problem statement behind doing this research or this project is that we have only very few data in some domains to be used for the deep learning. So as we know that deep learning needs more images to give quite generalized fitting over the data. So my intention is to see if we can use few data set to generate the similar kind of the data so that it can be used for the training processes, and we can multiply those number of the data so that we could use deep learning methods in this data. So the data augmentation methods, like there are different methods for doing the data augmentation. The one that we learned in our lectures and in lab are like single data deformations and multiple data mixings. But the one that I'm going to implement using the GAN is learning data distribution. So generally it's about looking in all the training data set and knowing the probability distribution of how that data is occurring in that data set, and trying to oversample those data so that we could produce more and more data of the similar kinds. So this is a working principle of the GAN to learn the potential probability distribution and oversample the data distribution to generate the new data. So it consists of the two working fundamental sectors, that are generators and the discriminators. Where the generator generates the data by learning the probability distribution in the data, and the discriminator is just like a a block which says whether the data is real or it's a fake one, and it passes the value of its output to the generator, and the generator learns more and more to learn the probability distribution and to feed on the probability distributions. So there are two methods of doing this. One is direct method and another one is indirect method. But probably in this project, I'm going to use the direct method where the input is given to the generator and also to the discriminator, and the output is passed to the generator again. So I have taken the references from this survey of the image augmentation, which is a conference paper that was published on Conference of Physics on this 2022 February. So method of evaluation. So when we are using the GAN and we have seen the output of a model, then there is one major challenge of evaluating whether how closely the data generated was representing the sample. So there are two types of the method. The first one is the qualitative evaluation, which means we see the data and we see like if it is suitable or not by our human eyes or by our expertise of the knowledge. And another one is quantitative evaluation, which researchers has been following in the recent research papers, where they use ResNet 50 models and Inception V3 models to find whether the data is accurate or not. So the use cases, it has been used in several recent topics, like in pedestrian recognition and like generating the remote sensing image scenes, where the basic architecture is like this. And this is taken from one of the paper in 2019, which uses the shifting GAN approach for generation of the more for the data augmentation technique. So the challenges here are like that I'm going to explore with in these projects are the challenges related to the GAN. So it lacks the supervision information guidance. That is what I got to know from the conference papers. So I would like to see if we can use some supervision information in training process. And the fitting process is random, so there is a lot of noise. And the interpretability, that means the output interpretability, is very poor, and the generated data sometimes looks 90% or 95% similar, so that there lacks the diversity in the generated data. And there are different methods to evaluate the GAN, so it's quite conflicting among the researchers to reach to the confusion, because it is totally a subjective manner if a data generated is actually representing our original data or not. So that's what I have thought, and the data set that I would be probably using in this is not yet fixed, but I would think I would go with the MNIST data set and try to replicate a few data and augment the data and see how the augmented data is produced and whether it can be further used in the deep learning as a training sample or not.
Okay. Any questions for Lab11? Are you still looking for partners?
How can you breathe when you present?
Okay. Yeah, so it's interesting. One thing you might want to look at is there's a some recent work on models related to this called diffusion models. So you might want to take a look at them. They try to come up with a more structured way to generate images from noise. And all these GANs, you take a noise vector and then try to turn it into an element of the data distribution, right? And they're notoriously difficult to train, right? Unstable and things like that. So yeah, anyway, you might want to take a look at diffusion models. Yeah. Then besides that, I guess you need to pick a specific domain or a specific problem, right? So you mentioned pedestrian detection. Is that or is that what you wanted to work on, or you're not sure yet?
I'm thinking about the traffic data set, Professor.
Traffic, like
Yeah.
cars and
Cars
okay.
and the road traffics that which will be useful for the CCTV object detection in further research.
Okay, so then if you're doing augmentation for detection, that's more challenging than for classification also, right? So yeah, you want to look closely at how to with detection. It's interesting, right? Because you've got the objects of interest, but then you've also got the background, right?
Yep.
And to synthesize a realistic looking image, you have to be able to synthesize both, right? So yeah.
So for this domain, I haven't found anyone doing with this kind of the augmentation technique, to my knowledge at least. So like there are some mosaic augmentation techniques which was introduced in 2011 or something like that. So I think that technique fits very good for the traffic object detection, but I'm trying to explore if it can be used or not. And the problem with the GAN is that to learn the generative, to learn the probability distribution, it needs a lot of the images. So like there will be some computational problem while using the GAN models, but since I have kept my domain very fixed that if we have a little amount of the data, then we're gonna see the practical use of the GAN model in that. So probably I would be using very few images to find their probability distribution and generate a new one. But as you said, in traffic data, like the object of interest is very small. So maybe the GAN model is not very much suitable. So I haven't considered a fixed domain yet, but I'll definitely try to do it with that and try to research on that more. If not, I'll be going to do with some scenes detection, like 3D scenes of the Greenlands or something like COCO data sets where the object of interest is actually covering a large amount of the area in an image.
Okay, yeah. These are all interesting ideas. The thing you mentioned, that the doing synthesis where the object of interest is very small and the background is large, you could consider making it so one of the types of GANs is a conditional GAN, right? That takes some input and then does something to it as part of the generative process. So you could take an image that has that's like an image of a traffic scene, right? And then you're supposed to basically maybe remove and add cars or vehicles or something like that to the scene, right? Which would be quite challenging, I think. Would be interesting. And so anyway, basically, if you fix the background, then it gets a little bit more. I suppose it's more tractable.
Yeah, I would need a lot of supervision from you, sir.
Okay, sure. Anyway, yeah. So when you want to talk more, when you maybe get a more concrete plan, then let's talk about it. You can just make an appointment with me.
Thank you, sir.
Okay, good. Other questions, comments? Okay. Go next. Are we going to finish on time, or are we going too slow? I guess we can make it, I hope. It's about 3 minutes per group or something.
Yeah. It should be in time.
Okay.
Okay. Land. Where is land? Okay. Sakip, Anjana, Ayman.
Okay. So hello everyone. Let me just share my screen. So this is our project. We aim to implement this land use classification use satellite image dataset, and our domain is like we will use satellite image to classify land, like such as we will try to identify forest, river, or industrial area or residential area. So we hopefully this will be helpful for some real life challenging, like in the domain of agriculture, forest management, or coastal and inland and water quality monitoring, or land ecosystem monitoring. And we think that this type of project might help in the efficient use of natural resources or lowering climate change, waste, and deprivation. So that is our very basic problem statement. We are going to identify some classes of the land like river, forest, industrial area or residential area, etc. And then Anjana will talk about the data set, although we have not fixed it.
Yes, we looked at a few data sets at the moment. So we found that agencies like NASA, USGS, and European Space Agency, they provide free and open access to some of their data sets from some of their satellites. For example, the Landsat satellite image data set from NASA and USGS. Also, European Space Agency, they has this Sentinel series of satellite, and out of them, there are 5 we can get the images from 5 satellites for free. So we are going to go through these data sets, and we only got time at the moment to analyze the Sentinel-2 data set. It has a data set containing 13 bands of data, including the RGB channels. So we will get those data sets and define 10 to 12 classes that we want to identify and try to classify them. Ayman, please.
Then we will build our own CNN model for the classification problem. Then we will use transfer learning using pre-trained models of some popular CNN architecture like GoogleNet, ResNet, etc. And finally, we will compare the performance of our models, implemented models. Thank you.
And there are few references. We went through these papers. Okay, thank you.
Okay, yeah, thank you. I guess the first, it looks interesting. The first point though is that I think this is not a classification problem. It's a segmentation problem, right? So you want to, I mean, these VGG, GoogleNet, etc. These are fine as backbones but you should be thinking about a semantic segmentation model. And you know, the famous one that's been used in this area is called UNet, right? That everyone sort of starts with. But there are many others as well. So anyway, so because the point is you want to classify each and every pixel in the image, right? So then when you have that situation, it's called semantic segmentation. Yeah, and then the other question is then what about I mean, you need some labels, right, to train with. So where are you going to get the labeled data?
So far, we found that Sentinel series of satellites, they have labeled data.
Okay.
According to the European Atlas.
Yeah, Professor, like there's a data set, Euroset. You already went through data set and it's already labeled.
Okay. So then it means that you have to correlate the labels from the European Space Agency with these images, or they're already
they are labeled, sir.
Okay. All right.
We have to, yeah, they provide a 13 band data set. The images are in TIF format, so we can extract the 3 RGB channels.
Okay, yeah, that's fine. But then I guess it leads to the question as to what's the use case, right? Because if the data already come labeled, then why would we want to learn to label them again? I mean, you know, for sure, the space agency themselves, they need to do that, right? Every time they get a new image set, they have to do it, right? But yeah, so what's your model going to? What's the use case for your model?
It's like, sir, we can monitor, say, for example, there is a particular area of land we are interested in monitoring, like deforestation. Is deforestation happening? So we can compare this year image, last year image with this year image and see what is the percentage of forest clearance likewise.
Yes, yeah, I fully agree. That's an important problem. But then still, what prevents us from just using the labeled data from Sentinel, right? And then just counting the pixels that are already labeled, right? And see if that's growing over time or something like that.
They are not labeling real time, sir. So.
Oh, you mean the images you have labels for is not all. It's just a subset of historical images.
Yes.
Okay. All right.
So,
I thought you were saying that they already provide the labels for all of the images, but no, that's not.
No, sir. There are few previously labeled data sets, so we have to build a model for learn from them, and then when the new images are obtained, we need to classify and, if necessary, see the changes.
Okay, yeah, that's perfect. Okay, got it. Anyone else have questions? Yeah, so take a look at the different state-of-the-art semantic segmentation models, then you probably want to look there.
Okay, sir.
Okay, thank you, Professor.
Very early segmentation model that is have very real time is a PID net. Maybe you can try.
PID net.
Yes, has the use the concept of the PID.
She's
It's
an
real time.
advertisement.
Yeah.
It's an advertisement. Okay. All right, great. Next.
Yield curve forecasting. Okay. Meow.
Good morning, everyone. Well, my project is to forecast the yield curves of Thailand, specifically the Thai government bonds. So actually, this project, I'm mainly referring to this PhD dissertation from the National Institute of Development Administration. And then actually this is quite a preliminary idea. I haven't read through the dissertations and all the other reference papers in details. I only have skimmed through them. According to my initial studies of the papers and the dissertation, the forecasting of the government bond yields in Thailand can be done by the following data. Okay, and then our target data will be the government bond yield of the Thailand. So, well, actually, there are a lot of government bonds with various time to maturities in years. However, I will probably choose about 4 or 5 out of these, less than, from 1 year to 10 year. So maybe like 1, 3, 5, 7, or 10. And then for these data points, for the features, actually, according to the dissertation, we can get it from the public data sets of Bank of Thailand and the Ministry of Finance, as well as the Stock Exchange of Thailand. And then as for the other, the US and the International Monetary Fund data, there are also public data sets available on the net. Yeah. And I haven't chosen any specific models to run, but these are a few academic papers about interest rate forecasting and the yield curve forecasting. So according to these papers, there are a few models that I can apply to this problem. So from the regression models, there is the linear regression, and then the Gaussian processes regressions, and then also most of the papers emphasize on the application of deep learning models on this problem. So I will probably use like 2 or 3 of them, okay, to do the to compare the models and the results. Yeah, so that's all. I've only prepared like 3 slides.
Okay, sounds interesting. So you're basically gonna explore or try to reproduce some of the work in this PhD thesis, right?
Yes.
Are the data there? Are they published? Everything is publicly available, and is it already organized conveniently, or you have to put all these different data sets together yourself?
Okay, correct. These data sets are actually publicly available. Like let's say the budget deficits, I can get it from the national accounts, possibly by the Bank of Thailand, and then the U.S. federal funds rates. There's also like historical data sets available on the net, and then the IMF also have the primary commodity prices data set. And as for the other data sets, I haven't researched in detail yet, but according to the dissertation, they are all available, from the public data sets.
Okay.
Yeah.
And then I guess one recent group of models that have been successful in this area very recently is the transformer models. So you might want to take a look at one famous one that performs very well in many applications, time series forecasting applications, is the temporal fusion transformers, or TFT. You might want to take a look at that, because and it comes with the software is very easy to use. The open source implementation is really good. Anyway, that would be one thought. And then yeah, are you willing to put your money where your model is? Meaning you're going to put some money into the recommendations of your model and see if you make some money by next month?
Well, it depends on the outcomes of the my models.
Okay.
Yeah, let's see.
Yeah, we'd love to hear that you built a model, and then you did some investments, and then made a bunch of money off of it. Okay.
Wow.
Anyway.
I hope so.
All right. Good. Any other questions? Okay. Yeah. Then good. So carry on.
Okay.
And we'll see
Thank you.
next time. Yep.
Yep.
Hi, Son and Min set on.
Another money-making group.
Money destroying.
Money destroying. Uh-oh, are they not here? Oh, okay. Well, okay.
No one.
Then
I
guess we go.
saw no one. Min, no one. Oh my God. Skip. Okay.
Maybe you could let them know that they missed the
Okay.
presentation.
Emotion. Hi, An Hồng Đúc.
Hi, Professor and everyone. We will do a project with topic speak emotion recognition. Objective get similar with audio dataset often by online resource. Identify different emotions such as angry, happy, etc. through voice. Scope of project input big audio as future, then predict the label emotion of the speaker. The labels are different kind of emotion. Dataset with the supercore git or .github or Kango includes various range of emotions. Implement support by various libraries such as like Rosetta, Skitlearn, Keras, etc. Useful functions like waveplot, spectrogram, chance, future adjustment from audio datasets. Thank you.
Okay, yeah, thanks. So this, yeah, it sounds interesting. So that then, I guess a couple things, right? I see there are lots of tutorials online for this, right? So I'd like to see that you do something that is your own work, right? And I guess it should be possible to kind of fix a use case or an application, right? Like how are we going to use this model, right? What kind of application would you want to use it in? Do you understand the question?
Yes, Professor.
Okay, yeah.
So the use case is maybe we will recognize the voice or the emotion of the customer through calls into center or something. That is the use case.
Okay, so you're talking to somebody on the phone and you want
Yes.
to know if they're upset or angry, right? Then maybe try to help them calm down or something, right?
Yes.
Okay, yeah, that's nice. Okay, I guess you have two things, right? You have the signal processing to worry about, and you have the time series classification to worry about, right? So it's a little bit complex, but yeah, most of these audio classification tasks, they work best on usually spectrograms, right? So you
Yeah.
take you do the signal processing to create a spectrogram at different points in time, and then classify those with a CNN or a time series based CNN, LSTM, things like that. So yeah, anyway, I think it'll be interesting. So then hopefully you'll be able to do an interesting demo at the project presentation day. And you'll be able to tell, yeah, if Alisa is happy, sad, or afraid, or angry, or disgusted based on her voice, right?
Yes. Thank you, Professor.
Okay, thanks.
So can I ask question?
Yeah.
Okay. What's the type of data set you got to training?
The type of data set is audio set.
Yes. What type? .mp3 WAV or what?
MP4. I think so. Actually, I'm propose a serial of data set. I'm not working on it yet.
You have to convert the
I mean
dataset
that
to
I search for several data set of the emotion of the speed, but I'm not work on the rosette of the the rosette. So I'm not sure with the type of the audio.
and the result output is can detect in real time or not?
Yeah, the results is just the recognition of the emotion.
Real time? When I speak to your computer and the computer show the emotion in text, something like this.
Sorry, I'm not sure about that. I'm not working on the project yet. Just the idea.
Yes, very interesting in your project.
Thank you. Thank you.
Okay. Then next. อืมอาทิแลมโบ
You see my screen?
Yes.
Okay. About my project topic is going to be a okay. What? Okay. I think it's missing something. I going to doing some work on the image captioning. Image captioning is mean that where we input the picture and its output is maybe a sentence of a word. But well, actually, I still don't know how to do. And my objective is to make an easy and understand and to make easy understandable model and also for fun actually. And I think if this thing is too easy, I think I maybe do something more on the image processing, image synthesis thing. Okay, and to I might okay. Sorry, where is my mouse? Am I using the what is it? Oh, Coco data set from Microsoft to make the model. And I'm not sure how to do, but yet I'm not sure how to do this yet, but I might search for how to do. And the idea is we have some image and the output will be a text like this one in the left hand side. And as you can see, is a lot of what I can see a sentence of a word. Okay, thank you. And yes, I think the data sets might be looking like this one. There might be an input side, but if my computer is not powerful enough, I might downsize the sample to 32 by 32 size of image. But I would like to still using the color image scale and T-layer. But for my plan B, I think if this is too easy, I might go with this one, but I'm not sure how to do. But yes. Okay, can I stop? Yes.
Yeah, I think this one is I mean there are lots of tutorials out there on this topic. So yeah, so you can make it easy or hard, right? So I think it'd be
I think I'm going to make it hard.
Yeah. I mean, not doesn't have to be impossible, but yeah. So maybe you want to look at some of the state-of-the-art models and then see if you can replicate them or you know look at different ways.
Okay, I have some question about this one. About this can be plus. Is it too hard to do or is it not? Because I don't understand on the GitHub, but on the paper is quite understandable. But when I look at the GitHub, I quite not understand.
Yeah, well, yeah, I think you should look at the paper, not the GitHub, right? So read and understand the paper first that they're referring to. But yeah, so you have to yeah, I guess diffusion models. I was just mentioning it to I think it was Biplav, right? And so that's kind of new. And then latent, these latent models, they're kind of confusing. So whenever you have a technique that has latent in the title, there'll always be complicated math, right?
I might remove the Latin word from this.
No, it's but I don't want to discourage you, right? So, but yeah, take a look at take a look at the paper, and then yeah. But what I don't want to see is that you just you know, maybe you find some code in GitHub and then run it, right? And
No. I will
right?
implement it myself.
Okay, very good.
Okay, thank you.
Okay, good luck.
Yes, thank you.
last two group. Sentiment analysis. Who is that? Sanya and Silipit.
Can you guys hear me?
Yep.
Good morning, everyone. Our project is sentiment analysis of Twitter data using machine learning. Everybody knows what Twitter is. It's a famous social networking site with over 200 million users. And there's 36 million tweets created per hour. I'm not sure these stats hold with Elon Musk in charge. But yeah. So what we're doing is sentiment analysis. What this is we look at the emotions and opinions and attitudes displayed through these tweets, and then we use this to classify them into positive or negative tweets. Since these tweets are text, we're going to use natural language processing to pre-process the data. Sunday?
Yeah, so our objective is to classify the tweet as whether they are positive or negative. So we plan to use different machine learning algorithms and compare the accuracy among them. So next, so basically, for now, these are the algorithms that we plan to use. And that's it.
Okay, yeah, thank you. So I didn't quite catch, do you have, where are the labels coming from? Do you have a big?
The data set is labeled.
Yeah, we have the data set that's labeled
We've got a data set full of millions of tweets that's labeled.
Okay, okay. Yeah, then I guess you may also consider some of the more natural language processing oriented models, right? So these are kind of basic ones, I guess, based on a vector representation of each tweet or something like that, right? Which, I mean, it's appropriate for the class, right? It's what we studied. But yeah, you might also consider to look at some of the models that are more recent in the NLP area. But yeah, I think it'll be interesting.
I think the initial challenge is going to be understanding the natural language processing itself.
Yeah, okay. Yes. Yeah, and then, yeah, I guess it's a timely topic, right? So Twitter's going crazy right now, right?
Yeah.
So let's see.
It would be interesting if we had post Elon Musk data set. So what are the sentiments pre Elon Musk and post Elon Musk?
Yeah. Okay, interesting. Maybe yeah, if you could use it to predict the United States election that's going on right now, it would be interesting also.
I think we can scrape the data and put it through the model.
Yep, good. Yeah.
I think Sirikit is so much interested to learn about Elon Musk.
Okay.
Who isn't? Thank you.
Yeah, some of us hope that he loses billions of dollars and then somehow has to give Twitter back. Okay.
Okay, the last group.
Last but not least.
Fake detection ท่านนิรุตเพราะฉะนั้น
We cannot hear you. Are you saying anything?
Okay. Good morning, everyone. our team do project about face detection and recognition. Member in our team is Pochanan, Nirut, and Tan. Okay, he sent to Professor Dr. Matthew, Associate Professor Dr. Mongkon, and Dr. Alisa. Okay, the objective of this project is to detect the face from the camera in real time and to study about the field of the image processing. The scope of the project, one is detect only human face. This one is trained from the online dataset. And another one is detect group member face using group member image with label. This one is trained from offline dataset. Tool we use language, Python, and device use personal computer with GPU and camera. The expect result, the project model able to detect human face in real time, and if it's possible, we will display the name of the registered person. Thank you. Any question?
So this one, you were asking everyone about real time, right? So this one's going to be real time, right?
Yes.
Okay, good. I guess one advice, the face detector that everyone uses for real-time detection is called MTCNN. So you might want to just use that one and maybe focus on the recognition, right? And then what will you recognize? MTCNN, yeah.
Yeah, MTCNN. Team, please note.
Yes. This one is this one's very popular. And then yeah, maybe you can recognize everybody in the Zoom, right? All your colleagues in this class, for example.
Thank you.
Okay, yeah, it's a fine. No, but do you know what approach you're going to use for the recognition?
Tan, please help. Team. We of course in the deep learning, but not specific yet in the detail.
Okay. Yeah, there's a famous one called FaceNet that is pretty works pretty well. But then there are more recent, more state-of-the-art models as well. So you can take a look at the current state-of-the-art and what models are feasible, right, to run on your resources, right? Okay.
FaceNet.
Yeah, it's called FaceNet. This one's quite popular. It's not the best, but it's popular and pretty good.
Okay, thank you, Professor.
Yep. Okay. Any more questions, suggestions? Okay. Very good. Then, so I think actually the projects look pretty interesting. I hope the final product matches the hype of the proposals. Let's see. Okay. Yeah, it's gonna be fun. So yeah, good luck to everybody. And then yeah, I think if you want to talk more, you need some ideas or advice, or just want to bounce your idea off us. Yeah, just make an appointment with me. I'm happy to talk more. Okay, good. Then see you tomorrow, right? And then we'll start to talk about reinforcement learning.
Yes.
Okay. Bye-bye.
Okay. Bye, Professor.
Thank you, Professor.
Yeah. Thank you.
Professor Matt,
Thank you, Professor. Bye-bye,
can I ask? I have a problem in the previous lab.
Okay.
We are saving accuracy and loss in data in arrays
Yeah.
for the deep learning CNN model. So those arrays are created in the CPU, not GPU, no? Only the
usually. Yeah. Initially, the loss tensor is probably on the GPU, but then you have to copy it to the CPU memory. Yeah.
Oh.
Yeah, if you want
I-
to plot or anything like that, definitely you have to move it from, if it's on the GPU, you need to move it to the CPU.
In the lab exercise, in the lab sheet given to us, without any problem, I can plot the loss curve.
Okay.
But when I try to plot the accuracy curve, it says can't convert CUDA 0 device type to NumPy. Use tensor CPU to copy the tensor to host memory first.
Yep.
When I check the type of this train accuracy, it's a list, and it says there's no attribute called CPU in it.
Oh, it's a list already. Oh, no, okay. Yeah, it's going to be a list of tensors, and those tensors are going to contain GPU data. So you need to dereference the tensor within the list. So it'd be like list square brackets 0, right, to access the 0th element of the list, and then dot CPU, and then that will copy the contents of that tensor to the CPU. That's probably what's happening.
Oh, I see. I was trying to convert the list directly
Yeah,
to
yeah.
the CPU.
Yeah, the list is already on the CPU, but the tensors inside the list are mapped to the GPU.
Okay, thank you, sir.
Yep. Okay, good luck.
Professor, can I get 1 more minute?
Yeah, sure.
Yeah, maybe I share my screen to make it. Yeah, can you see my screen, Professor?
Yep.
So this was one research that in Japan, Tokyo University of Tokyo, I think they did it. So this was for reproducing the X-ray chest X-ray images. So they use this kind of the model here, which consists of some residual blocks and some inception blocks to generate the image. So this is, I think, quite different from the model that you suggested me, consisting of the conditional GAN.
Yeah. Can we see
So
the model again though?
Yeah, Professor. Sorry. Yeah.
Okay.
That's right.
So the generator. Well, it looks kind of like it's kind of weird, right? So
Yeah.
it's got the Z vector, which is normal for a GAN, and it's
Mhm.
also got the image, right? And I guess they're going to take this image and then generate a new
image
that is of the same class, but just a different one from the same distribution or something.
Yeah.
Okay. Yeah. So I guess I guess it's a type of. It looks kind of like a conditional GAN, right? In terms of the inputs and the outputs. Then I don't understand how I don't know what this trapezoidal block is supposed to be doing, right? To
Yeah,
turn the image into
this
something,
one, right?
Yeah.
Yeah, I think it's talking about these inception blocks and the residual blocks that they have given. So like this was the basic idea that
that part's quite normal, right? You take a simple this noise vector, and then you have a series of convolutional layers,
Networks.
right? That will
Yeah.
make it into a two-dimensional image.
Yeah,
So
and they
that's all
probably
fine.
stack it over here.
Yeah, and yeah, residual blocks, inception blocks, this is all good. But yeah, what I don't know about is how they incorporate or maybe it's an encoder. This thing at the top, maybe it's some kind of model that turns the image into a fixed length vector representation, right? So that's the job of an encoder. It will take an arbitrary input and then turn it into like a low dimensional single vector representation, right? That is supposed to capture the information in the original input. That's probably what this is supposed to be, I guess. So anyway, so yeah, so it looks like they take the noise and the encoding of the image together, and then they use that to generate the output image, which yeah, so it's a type of there are models that are like this called what's the name? Now I forget. To remind myself of the Um, Yeah, I guess there are lots of these models that anyway, the encoding of this input, it's usually they're called like latent encoding models, right? And so there's something there, right? That they're not saying how it's done exactly, right? But
Yep.
but anyway, this is a fine way to do it, and it's pretty similar to the conditional GAN as well, right? I mean, finally, the result is gonna try to generate a sample from the data distribution. So however it does that, that's fine. As to how to encourage it to, I mean, if your goal is to lay cars on top of a background image, right, like a traffic scene, then yeah, I guess still the discriminator would help to reject anything that is implausible, like a car floating in the sky or something like that, right? Yeah, so it could be an interesting approach to try. Either the normal conditional GAN or this one. I think they probably both have a good chance to work. Of course, training GANs is always hairy and difficult. Yeah, but if you can basically have to find the right hyperparameters and the structure of the network that can make it work. But yeah, this would be interesting.
Yeah, I found a lot of like gaps in GAN because this is a new topic, and I think a lot of research is remaining for it to mature over the time. So I chose this topic for that to understand about the GAN actually. So like even if I get 10 or 20% of accuracy by in a visual data, then I can continue along with this project, right?
Yeah, sure. Yeah, it's a good idea.
Yeah, and for the traffic augmentation, I have like gone through few papers. So they are all proposing. If I see the recent papers, they are all proposing a very unique type of GAN that has their own inputs and some kind of feature mappings that they have used. So probably like this is very hard for me to implement within 1 or 2 weeks to understand everything like that. So probably I will cascade and make my own architecture and try to use some of the key features that has actually made the impact, and try to make a network of my own for the generator. So that is what I was planning. And if I cannot like produce a result for the traffic data set, then yeah, like I said, like that chest x-rays, and they are like they are very domain specific, and they are just a picture, and like we can implement it, I think, with a fine accuracy. So the data set is not fixed, but I'll try with the traffic data set as much as I can.
Okay, yeah, I think you have a good plan.
Yeah, thank you very much. I'll do some research, and probably next week I'll book a time with you.
Okay, perfect.
Yeah, thank you, Professor.
All right, good luck. Take care.
Thank you, sir.
Yep, bye-bye.
Good night, sir.